Today, we will take a look into how can we find payments using an interest formula. Now, the main idea here is that when it comes to interest formula, most of the problems are going to be given to you in word problems. And in any word problem, we first need to understand what each variable represents in any formula. Then we can use the value for those variables in the formula. So keep that in mind. In any word problem, we need to figure out what each variable stands for, because most likely that will always give us a formula. And after we know what each variable stands for, we want going to try to find the value for those variables, and then we're going to plug it in to the formula. Let's get started. What we have to do here is to first, let's understand the given scenario. What it's explained here is that using the formula below, okay, so let's stop here. So we want to use this formula because that's what it says here, using the formula below. So we want to use this formula. Now notice that this formula has plenty of variables. So what we have to do here is to figure out what's the meaning for each of those variables, which they're given to us here. There are 4 variables in this equation here, where Pn is the present amount borrowed, which, when it comes to interest formulas, that is the original cost minus the down payment. N is going to be the number of monthly pay periods. PM is the monthly payments. And I is the interest rate per month. Notice that in this equation, there's only 4 variables present here. And this is what each of those variables represent. To make some space, I'm going to move this here, which we know that this is for the present amount borrowed here, which is the original cost minus the down payment. We know that if we want to use this formula, we have to find a value for each of those variables. So that's our first task. Let's actually read down the problem and see if we can figure out the value for each of those variables. It says, using the formula below, we want to determine the monthly payment on a 3-year loan, 3-year car loan. So notice here that we can use this information to give a value for n, which is the number of monthly pay periods. In this case, we're talking about 3 years. We know that each year has 12 months. So that means that in 3 years, we're going to have a total of 36 months. So we're going to have a total of 36 monthly pay periods. If we continue reading this with a monthly percentage rate of 0.400%. So here, they're giving us the percent rate, which is 0.400%. So we can use that to give a value for I, which is the interest rate per month, which this is equal to 0.400%. But remember that we don't use percentages in our equations. We need to convert this into a decimal form. So we have 0.400. We need to divide it by 100 to make this into a decimal. So that means that we have, or this is equal to just 0.004. Let's continue reading to see if we can find out the value for any of those variables. Now, it says for a car with an original cost of 5,000 and a down payment of 300. So notice that we can use that information to figure out the present amount borrowed, because we know that Pn it's equal to the original cost minus the down payment. Well, we know that the original cost is 5,000. And we know that the down payment is 300. So that means that Pn has a value of 5,000 minus 300, which is a value of 4,700. Now the question here, what is the monthly payments? Because they're asking us here, determine the monthly payments. So we want to figure out what's the value of PMT, which is the monthly payments. This is the unknown. So notice that we have a formula. Notice that we have a value for each of those variables. We know what we're looking for. All we have to do now is plug that information in. P of n, which we found it to be 4,700, is going to be equal to PMT, which this is the unknown. Now we're going to open a big parenthesis, and this is going to be 1 minus 1 plus I, but we know that I is 0.004. Exponent of negative n, but we know that n is 36. And everything is going to be divided by the interest, which we know it's 0.004. Close parenthesis. So this is what we have right here. But again, what we want to know is PMT. Don't confuse PMT as 3 variables. It's just one big variable whose name is PMT. How can we figure out what PMT is? Well, notice that here that we're multiplying. This is nothing more than a big number. Let's figure out what this number is. One thing that I'm going to suggest is first figure out what the numerator is, and then you will going to divide it by the denominator. So we're going to have 1 minus, open parenthesis, 1 plus 0.004. Now we're going to close the parenthesis here, and now we're going to put an exponent of negative 36. This is what we have on the numerator. So this is what we have. We're going to press enter. And this, we still need to divide it by the denominator, which is, so we're going to press division of 0.004. So that means that the right side, we can rewrite the equation now, because now we have 4,700 equals PMT times 33 point, let's round this to the nearest thousand, so that's 3 numbers, 466. That's fine. Remember that here we're multiplying. We're getting a little bit closer to it because we know we're multiplying. We're multiplying by a number. So if we want to leave PMT by itself, we have to divide. Now this cancels out. And now we know that PMT is 4,700 divided by 33.466. Let's figure out what that is in the calculator. So we got 4,700, and we need to divide that by 33.466. There's an extra 6 there. Perfect. So that means that, let's correct that. We have a monthly payment of 140 and 44 cents. Now, for your entrance ticket, in your own words, define what a principal is, what a down payment is, and what an interest is.